Okay, sorted, guys. All right, there we go. Microphone is working. All right, so 2.1 and 2.3, these are the ones you have to do for homework, so you can take a look there. In 2.1, remember what I wrote on the actual question, I'll take this off now again, is if in the question they've given you the symbol, right, they've written it as the statement, then that is the correct order of the letters. Okay, you don't still have to try and find the correct order. The same thing happened in 2.3 as well. They've used the symbol, so that is actually the correct order. Okay, so 2.1, we did speak about this quickly in class. Obviously, we can see that F is equal to S. All right, they're both 90, so that's given. Then this 17 degrees we calculated, all right, by saying 180 minus 90 minus 73. So we can't say that E is equal to R because of given, all right, because they didn't give us the size of E. We had to calculate it using angle sum in triangle. Okay, so that must be your second reason. And then your third reason, G equal to T. Remember, you don't actually have to calculate it because we know that we're going to get the same answer. Because if I said 180 minus 90 minus 17, that should give me 73. And I have the same two angles here. So this angle I'll also get by saying 180 minus 90 minus 17. Okay, so I will definitely get the same answer. I don't even have to calculate it. Okay, but the reason they must still be angle sum in triangle, because that's how I know that they'll be the same. Because I'm going to say 180 minus the same two angles. Then you write your statement. We call this the similarity statement, where you actually say this triangle is similar to this triangle, and the reason there is equiangular. Okay, because it's the angles that we've used. Then for the second one, for 2.3, that's where you have the smaller circle drawn on the inside of the bigger one. Now, guys, I'm not sure if I reminded you of this, but remember with congruency, we also spoke about this. If you write ABC first, you have to put all the information of ABC first. Okay, so you might have your fractions the other way around. You might have 1/3 for your fractions. That's technically still correct, but you might lose a mark for your order. Okay, so if you did that, if you wrote ABC and then EFD, all the sides of ABC must be at the top of the fractions. Okay, so I'll just show you quickly. Triangle ABC was actually the bigger one. Okay, so you would have to take 15/5, not actually 5/15. Okay, you would still be able to prove that they're similar, but you might lose a mark for order. So just check there. If you wrote ABC first, then you have to have 3 as your 3 numbers there. Okay, it's always the one that's written first at the top of the fractions. And remember how we do this is we look for the shortest sides in both triangles. So that was 15 in the one and 5 in the other one. And 15 divided by 5 is 3. Then we look for the middle sides, all right, which was 36 in the one triangle and 12 in the other one. 36 divided by 12 is 3 again. Then we look for the longest sides in both triangles, which was 39 and 13. And if we divide those, we also get 3. Therefore, and here, guys, I am going to go over quickly how you can check the order. They gave us the correct order, but they might not always do that. Okay, so I just want to go over that again quickly. But the reason there is then sides in prop. Okay, just quickly how we would choose or how we would figure out that order. If we wrote A, B, C, A in the big triangle is opposite the 36 side. And if we're looking at this big triangle, 36 is the middle side. Okay, so now we need to write the letter in the small triangle that is also opposite the middle side. And the middle side of 5, 13, and 12 is 12. Okay, so we're going to go with E. If we wrote A first, we have to write E first. Next, we wrote B. Now, B is opposite the shortest side. So in the other triangle, which side is the shortest one? The one with the length of 5. And the letter opposite that side is F. All right, so I have to write F second. And then I wrote C, which means that I must write D. Okay, the last one that's remaining after that. Okay, Now, guys, I want you to continue with number one. I'm not going to teach you anything new today. You're just going to practice more of these. I'm going to give you some more from the answer series as well. Okay, because next week we need to start applying similarity. So it's very important that we can do these proofs easily. Okay, so you're finishing up number one, which is, remember, you're not actually proving it. You're just saying whether they are similar or not. Then I want you to do 2.2.1 and 2.2.2. Now in these two questions, you are going to prove. Okay, so you're going to do it like we did here, where you have your 5 lines. So these two questions are to prove. Now I just want to show you those questions quickly because they are a bit different from the ones that we've done so far. 2.2.1, do we see that they haven't actually given us any sizes of these angles, right? They've put a little 1 there and a 2 there. That's actually just saying that this is M1 and that's M2, okay? Because it's not a 1 degree. So they're not telling us that the size of that angle is 1 degree, all right? It's just a little 1, just saying we can call that M1, that's M2, this is N1, and that is N2. Now, guys, have they given us any information about sides? No side lengths, okay? It's not a trick question. They haven't filled in any values on the sides. So we can't possibly use sides in prop. They haven't even given us one side, okay? We can't use sides in prop. We have to work with angles. Now, guys, the fact that they told us that these two lines are parallel, that is the key to proving that these triangles have angles that are the same. Now here they're saying triangle MNX, which is the top triangle, right? Do we see that? And triangle YZX, which is YZX, which is the big triangle as a whole. So the small triangle is actually a part of the big triangle, right? Do we notice that? So we need to try and prove that the 3 angles in the small triangle are equal to the 3 angles in the big triangle. Now guys, isn't X an angle in both of them? Look at angle X. Angle X is an angle in the small triangle, but it's also an angle in the big triangle. So we're actually going to say that angle X is common. Do you remember when we did congruency, we often had that with a side, all right? If the two triangles were drawn next to each other, we said that a side is common. We did that often. But it can also be the case for an angle, all right? Because that is the small triangle. We see that X is an angle. That is the big triangle if we just ignore that line. X is also an angle in that triangle, all right? So does it make sense that X is common? So that can be the first one. I'll write it here on the side. I'm going to post a picture of this again. So you're going to do your whole in triangle, this, and this will be number 1. X is common. What else? Can I use those parallel lines somehow? Do we maybe, yes, Hannah? Remember, we're not doing sides, we're only doing angles. They're not equal, they're just parallel. Okay, yes, Naomi? Corresponding angles, well done. We have an F shape. Do we notice that? And there we have another F shape, all right? So in the F shape, corresponding angles are equal if they have parallel lines. So that angle M1 is going to be equal to angle Y, right? Do we see that F shape there? Because of corresponding angles, MN is parallel to YZ. Don't we have the same thing on this side? Right? N1 will be equal to angle Z. Again, because of corresponding angles, we have an F that's just facing the other way. Corresponding angles, MN parallel to YZ. All right, and there you have your 3 angles. So X is common. M1 is equal to Y, corresponding angles. And N1 is equal to Z, also corresponding angles. Okay, so guys, they're not always going to actually give you the sizes of the angles. Sometimes you need to use things like parallel lines to actually try and prove that the angles are equal. Okay, we have to do the same thing in 2.2.2. Again, they haven't given us any sizes of any angles, but we have that lines are parallel. So do we see that there's a Z shape over there? And there's a Z shape over there. And we have vertically opposite angles. All right, so for none of these reasons in these two questions will you be able to write given, because they haven't actually given us any of the angles. All right, but we can still prove that three angles are equal. Here we're going to say angle A is equal to angle C. What do we call the Z shape again? Alternate angles. All right, AB is parallel to CD. Then we're going to say B is equal to D, because we have another Z shape there and the lines are parallel. So for that, we're also going to say alternate angles. AB parallel to CD. Then for our third pair of angles, remember we can always say angle sum and triangle, or we could say angle. Now you can't just say E is equal to E. All right, you have to name them properly. So what is this E angle's name? AEB. Right, you have to name it like that, because they haven't also put little numbers in there. If they put little numbers in there, that would have been nice. Okay, then we could have just said E1 and E2. But guys, if there are no numbers there, you can't just invent them. Okay, then you have to name the angle properly. So we're going to have to say AEB, that's the top one, is equal to, the bottom one is DEC or CED. It doesn't actually matter which way around you go, as long as the E is in the middle. Okay, because that's where the actual angle is. So DEC. And what do we call these angles? Vertically opposite angles. All right. So I'm going to write the rest down. I want you guys to be able to write it down yourselves. Okay, but does that make sense? They're not actually always going to give you the sizes of the angles, and you can't always calculate the sizes of the angles like we did in this one, where we could actually calculate 17 and 73. Okay, sometimes you need to use geometry knowledge, like vertically opposite angles, like corresponding angles, like alternate angles, in order to prove that these angles are equal. Okay, so I will post a picture of this bit. And of this, actually, I'm going to post it properly. All right. So I put it on the stream, but I'll just put it in the announcement. So you're doing these questions from exercise 1. Plus, I'm going to give you a few questions from the answer series, which I'll also post in the announcement just now. Okay. So keep working on number 1. And then once that announcement is up, you can work on the rest. Okay, guys, I'm just going to put number 1 on the board. Actually, then it's a bit easier. Then you don't have to look at your phones right now. Okay, so number 1 is over there. I'm going to zoom in, see if that helps. There you go. Okay, so finish that and then check classroom for the rest.